Alright guys, welcome to another video. So we're still continuing work from the previous video, solving for x using some applications of law 1. Now, quick recap. I said that if I have two bases, right, with different exponents that are equal to each other, the bases have to be similar, by the way, then their exponents are going to be equal to each other. Okay, so that's what we need to apply when actually solving for x in this case, when dealing with exponents. So what I have is 7 to the power 4x is equal to 49, right? For me to easily solve this problem, I have to change the base of this problem to 7 to the power of something. All right, 7 to the power of something. So that's the thing I'm going to do. I have to write 49 in an exponential form. So what I will have is 7 to the power of 4x is equal to 49. When written in an exponential form is actually 7 to the power of 2. So what I will have is 7 to the power of 2, right? Now that I have two bases on either side of the equation that are similar, it means that I have to make their exponents, the exponent of these two bases to be equal to each other so that I can solve for x. So what I will have is 4x is equal to 2. Because I only want to remain with x alone on the left hand side, I'm going to divide by 4 on both sides since I am obviously solving for x. Then my final answer will therefore be, x will be equal to 1 over 4, right? No, 1 over 2, sorry. My answer will be 1 over 2. I'm hoping so far you are getting these problems and how is it that you're supposed to work on them. The next ones I want you to try by yourself first before looking into the video and see how is it that you're gonna fare. All right. Okay, here's another one. Please try it yourself before before checking the video. Please pause the video and do it yourself. So here we have a to the power of x times a to the power of x plus 5 times a is equal to 1, right? And we are expected to solve for x. So I hope you've tried the problem. Now let's do it. The first thing that we have to check out is what do we have here? We have three bases, right, that are similar to each other, and these bases are multiplying each other, as we can see with the dots there. So these bases are multiplying each other, meaning that we have to put the exponents of these three bases under one single base of a, right, since they have a common base. So that's what we're going to do. We will have a to the power of x plus 5 plus 1, because here there's 1, obviously, since there's no number, we know that it's actually 1 that's there, is equal to, we have to change this 1 to a base of a to the power of something. All right, now this is another law of exponents that you should know, and we'll see it in the next coming videos, that anything to the power of 0 is 1. So for us to change this 1 to be something with a base of a, will what we'll do is say a to the power of 0, because we know that anything to the power of 0 is 1. So this one is actually equal to a to the power of 0. Okay, now that we have similar bases on both sides of the equation, on the left and the right hand side, we have a base of a. It means we can make our exponents to be equal to each other, right? The exponents of these two bases that are similar. So we will have x plus 5 plus 1 is equal to 0. Then from here we will add our like terms. We'll first start with x plus x, or rather 1x plus 1x, since these two are like terms in terms of having a similar variable. So x plus x will give us 2x, and then 5 plus 1, they are both numbers or constants, so 5 plus 1 gives us 6 is equal to 0. We want to solve for x. So we take this 6 to the side, and since it's positive on the left, when it goes to the right, it will be negative. So we will have 2x is equal to negative 6. And then we will divide by 2 on both sides because we only want to remain with x alone, right? Then this 2 will cancel with this one. Therefore, x will be equal to, what will x be? X will be equal to negative 3. And just like that, you have solved for x. All right? You solved for x. So that's our answer. Let's go to the next problem. I hope you got it right. If you didn't, just check where is it that you made a mistake. Okay, here's another problem. Please try it by yourselves and then find out what you want to get as an answer. Then, yeah, you check after pausing the video on whether or not you got the answer correctly. So this is the problem. 2 to the power of x plus 1 plus 2 to the power of x plus 2 to the power of x minus 1 is equal to 28. Try it and then see what you get. I'm hoping you've done so. Let's check it out. So the first thing that we do, right? The first thing that we do is to reverse here, all right? We want to reverse, meaning we want to go backwards. At the moment, we are here. A to the power of m plus n. We are here, so we want to go here first. I mean, after. From here, we want to end up here. A to the power of m times a to the power of n. All right? That's what we want. So we're going to write the exponents of x plus 1 under the same base of 2 and the exponent of x minus 2 under the same base of 2. All right? Let's do that. So what we will have is 2 to the power of x times 2, right? We know that when we multiply these two bases, the exponents are going to add. So we've worked from here to here, from here to here, all right? Plus 2 to the power of x, we write it as it is, plus we write in these exponents under one base separately, 2 to the power of x times 2 to the power of negative 1 is equal to 28. Then from here, what we are going to do is to look for our like term. All right, we're going to factor out, not our like term, sorry, but our common factor. So we're going to factor out 2 to the power of x as it appears here, here, and here. All right, I'm factoring out 2 to the power of x. When I factor out 2 to the power of x here, I remain with 2. Plus, when I take it out here, I remain with 1. When I take it out here, I remain with 2 to the power of negative 1 is equal to 28. Right? Now, this thing should give me one number. So I will have 2 to the power of x is equal to, when I punch on the calculator, let me just quickly punch on the calculator, I'll have 2 plus 1 plus 1 over 2. This 2 to the power of negative 1 is same as 1 over 2. I get 7 over 2. 7 over 2 is equal to 28. I'm going to divide by this 7 over 2 on both sides of my equation. 7 over 2, dividing by it, 7 over 2. All right. If I have a double division, I have to change this division into a multiplication, or and then have this change into its reciprocal. Since it's 7 over 2, it will change into its reciprocal of 2 over 7. So this side, 7 over 2, cancel with 7 over 2. I will remain with 2 to the power of x is equal to 28 times 2 over 7, right? And then I will have 2 to the power of x is equal to, can quickly do this on the calculator. 28 times 2 over 7 is 8, right? We get 8. When we proceed, we should write 8 in its exponential form. So what we will have is 2 to the power of x is equal to 8 in its exponential form is 2 to the power of 3. Because my bases are similar on either side of the equation, I'll make their exponents to be equal to each other. Therefore, x will be equal to 3. And then you solve this problem. Okay, here's the last one. So we have 5 to the power of x plus 1 plus 5 to the power of x minus 1 is equal to 26 over 25. So what we must do is move from here to here, move from here to here. All right. So we are going to firstly start off by writing these exponents under the same base of 5 separately. Right. So I'll have 5 to the power of x multiplied by 5 to the power of 1, which is invisible, plus same thing that I did here, I'm going to do on this side. So I'll have 5 to the power of x times 5 to the power of negative 1 is equal to 26 over 25, right? Then on the right hand side, I'm going to factor out 5 to the power of x, okay? When I factor 5 to the power of x, when I take it out from here, I remain with 5 plus, when I remove it here, I remain with 5 to the power of negative 1 is equal to 26 over 25, right? When we proceed, this should give me a single number. So I'll have 5 to the power of x in brackets 5 plus 1 over 5 is supposed to be 26 over 5. 26 over 5 is equal to 26 over 25, right? When we proceed, we're going to divide this side. So let me just share. So we're going to divide both sides by 26 over 5. Same this side, 26 divided by 5. This will cancel with this, right? Then we will remain with 5 to the power of x is equal to, on this side I will have 26 over 25 multiplied by 5 over 26. You're going to get the same answer when you just punch this on a calculator. So the 26 will cancel with the 26. Then I will have 5 to the power of x is equal to 5 divided by 25 should give me 1 over 5. When I proceed, I should change this into a base of 5 to the power of something. So what I will have is 5 to the power of x is equal to, we know that when we have 5 to the power of negative 1, we end up with 1 over 5. So if we have 1 over 5, it means the 1 over 5 will change to 5 to the power of negative 1. Therefore, x will be equal to negative 1. And that's how you solve this problem. So we're done with law 1. Now we're going to jump into law 2 in the next video. I hope you understood what you are supposed to. If not, feel free to ask questions on the comment section and kindly like the video and of course subscribe to the channel. Bye.